Hey Math 146 students, this video is for section 8.1 where we're looking at an introduction to statistical tests. And specifically what we're talking about is the notion of hypothesis testing. So in chapter 7 what we were doing was we were trying to estimate the value of a population parameter when using information from a sample, when using a sample statistic. What we're going to be doing in chapter 8 is we're going to be taking a claim about a value of a population parameter and using information from the sample, using a sample statistic, to see if that claim seems to be reasonable or not. Now this section that we're dealing with today, section 8.1, is primarily a theoretical section. You're not going to be doing any computation in this section. We're just going to be looking at terms and definitions and theory. Okay. So here's what I would like to do. I want to give you some definitions, and I want to give you some examples of those definitions as we go through. So when we're doing hypothesis testing, the first step in the process is stating your hypotheses. And there will be two of them. There's the one that's called the null hypothesis, and it is signified by H sub 0. The null hypothesis is usually a statement of equality or of no difference from a historical value or a claimed value. And your null hypothesis will involve the symbol for a population parameter, so you could be dealing with mu or you could be dealing with p. There will usually be an equal, actually there always will be an equal sign. And then there'll be something on the right hand side here, usually a value. We're going to start by looking at just single values. Okay. As an example, let's ignore p for right now. As an example, let's say that I had a hypothesis that for the past, let's say, several years, average income in, let's say, Bellingham was $54,000 annually per household. So $54,000 annual household income. And let's say that that is the statement of equality or no difference from a historical value or a claimed value. Right now I'm claiming that over the past several years, the annual household income in Bellingham has had an average, population average of $54,000. Now let's say that something has happened, maybe the downturn in the economy has made me think that maybe this value isn't accurate anymore. So then I'm going to propose an alternate hypothesis. And that will either be signified by H sub 1, that is the notation that your book uses, or some textbooks will use H sub A for alternate, but this textbook uses the H sub 1 to signify the alternate hypothesis. So here's our null hypothesis, that the mean annual household income in Bellingham is equal to $54,000. Our alternate hypothesis, this represents the statement we will adopt if there is enough evidence to reject the null hypothesis. Okay, so if it turns out we collect some data and the data that we collect make this seem to be an unreasonable value, then we would end up rejecting the null and showing evidence in favor of the alternate hypothesis. Now you have three different options for your alternate hypothesis. One is if your alternate hypothesis is less than some number. You can also have a greater than, or you can also have a not equal to. Okay, so there's three different types of hypothesis tests we can run. And what type of test we run will depend on the wording that's given in the problem and what it is that we suspect is going on. So in this scenario with my $54,000 annual household income, where I'm thinking that the downturn in the economy has caused the annual household income for Bellingham to decrease, I would be selecting this first option. I would be selecting the less than. So right now I've got two competing claims. The predicted value or the historical value that the mean annual household income in Bellingham is $54,000, and now I'm saying, is there enough evidence to show that it's actually dropped below that it's less than $54,000? If we were testing to see if it had increased above $54,000, we would be running this type of test with a greater than. And if we were just testing to see is it now different from $54,000, but we didn't care about the direction, we would just use a not equal to. And each of these types of tests has its own name. If your alternate hypothesis is a less than symbol, that is a left-tailed test. If you're dealing with a greater than symbol, that is a right-tailed test. And if it's a not equal to, that's what's called a two-tailed test. But for our example, we've got mean equal to 54,000 for our null, less than 54,000 for our alternate. After we state our alternate hypotheses, then usually what will happen excuse me, is we decide what type of test to run. Okay, so this will be option number one. Option number two, or not option, step number two, decide on type of test to run. And basically, this is what we're going to be talking about for the rest of Chapter 8. Today, we're just getting an introduction to the entire process of statistical testing. But Chapter 8 is all about how do we know when to run which type of hypothesis test. Just like in Chapter 7, we were looking at how do we know when to compute which type of confidence interval. And for each test, we will have different criteria that need to be satisfied. Okay? So we state hypotheses, we decide on the type of test to run. Then, step 3, we actually run the test, and this is done in the calculator, to obtain what's called the p-value. Okay, so this part will be done in the calculator, actually running the test. And the outcome of that is we're going to get this thing called a p-value. So let me tell you a little bit about what your p-value represents. The p-value represents the probability of observing the results from your sample if the null hypothesis is true. So let me give you an example. We've got our null hypothesis that the mean annual household income is $54,000. We have our competing alternate hypothesis that the mean annual household income, has dropped below that. Okay. Now, let's say I went out and I collected a sample, and let's say my sample size was 500 homes, so it's a nice large sample. And let's say that the average annual household income in the sample, X bar, was, let's say, I don't know, $53,000. The question then becomes, is that sample mean low enough to call this value into question? Is 53,000 far enough below 54,000 to make you think that the actual true population annual household income has dropped below 54,000? Now at 53,000, we probably wouldn't be very swayed by that, right? There is some natural variation from sample to sample. Those values are pretty close. That could just be because of the 500 households that were included in the sample. So maybe that's not persuasive. What if instead of this scenario, what if we selected randomly 500 households to include in the sample, and our sample mean came out to be, I don't know, $56,000? Would we end up saying, oh, now the mean of $54,000 doesn't seem reasonable? Well, probably not. Again, these are pretty close values, and also this would not help to support our claim that the mean has now dropped below 54,000. So in that scenario, we wouldn't end up doing this either. Okay? So the probability, the p-value, the probability of observing $53,000 as our sample mean, if our population mean is actually 54,000, the p-value should actually be very high. We should observe this quite frequently if our mean were actually 54,000. That seems very reasonable, so it should have a high probability associated with it. Same deal here. If our mean is actually 54,000, how likely would it be to observe a sample mean of 56,000? Probably pretty likely. So we would expect a high p-value here. Now, let's say instead that we had collected a sample of 500 households, and our X bar came out to be, let's say, 38,000. Now we're looking at this and we're saying, okay, if the mean annual household income were actually $54,000, how likely is it that I would observe a sample mean of $38,000? How probable is that? That's going to have a very low probability. Okay, this would be very unlikely to happen by chance if the mean were still 54,000. At this point, it is much more likely that our mean has actually dropped below 54,000. So when we run our test and we get our p-value, low probabilities tell us to reject the null hypothesis because that doesn't seem very likely anymore, and instead conclude in favor of the alternate. Okay, so when we run a hypothesis test, we're going to get a p-value. High p-values don't really tell us anything. The null hypothesis could still be reasonable. Low p-values tell us that our null hypothesis doesn't really seem reasonable anymore, and we should instead conclude in favor of the alternate. So step 3, we run the test, we get the p-value. Step 4 is where we actually conclude the test. And we do this by comparing the p-value to the level of significance, which is called alpha. This is something that you actually set at the very beginning of the study. You decide how much error you're willing to tolerate, and on the basis of that, you set this value alpha. We'll talk more about that in just a second. But basically, the way that you conclude the test is if your p-value is less than or equal to the alpha level you've selected, then you reject the null hypothesis and conclude in favor of the alternate. If your p-value is greater than your alpha level, then you retain the null hypothesis, or you fail to reject. Okay, so 2 different ways you can phrase that. And the handy mnemonic device for remembering this is if the p is low, the HO must go. So So if your p-value is lower than your alpha level, you reject the null hypothesis. And then your very last step in hypothesis testing is to interpret these results in context. And what I mean by in context is you don't just want to go to, if we're on the board of directors for Section 8 housing, for low-income housing, we don't want to go to that board of directors and say, okay, we calculated the p-value, it was lower than our alpha level, therefore we rejected the null that the mean was $54,000. That's not helpful to them. What we instead say is, oh, we conducted a hypothesis test, and we were able to show that there was enough evidence that the average annual household income in Bellingham is now less than $54,000. Okay, that's the in context piece. And that's the whole process of hypothesis testing. What we're going to do throughout the rest of Chapter 8 is just fine-tune this. We're going to look at different ways to calculate the p-value and what tests to use under which circumstances. The last thing that we want to talk about today is this alpha level. What is it? Okay, and what does it do for us? In your book on page, let me find it for you. Oh, whoops, sorry. It's on page 416. There is a table looking at two different types of errors. When we conduct statistical tests, it is always possible that we made the wrong decision. Because maybe our sample was just a particularly odd sample. When we're sampling randomly, that can happen. We want to minimize the probability of making an error, but we never completely eliminate it. And when we're looking at hypothesis tests, there's essentially two different types of errors that we can make. So if we think about our null hypothesis is either true or our null hypothesis is false. But we'll almost never be in a position to know whether it's true or false. All we get to control is whether we reject or fail to reject the null hypothesis. So if we reject the null and if we reject the null and the null is true, we've made a bad decision. Right? If the null is true, we would want to keep it. So if the null is true and we keep it, that's okay. We've made a good decision there. If the null is true but we mistakenly reject it, we have made what statisticians call a type 1 error. Similarly, if the null is false and we reject it, that's a good decision. We would want to reject a false null. But we could end up mistakenly retaining it, and if we've done that, we've made a type 2 error. Okay. Now, the alpha level that we set at the beginning of this whole process, the thing that we end up comparing our p-value to, represents the probability of making a type 1 error. So right at the beginning of the whole process, we decide how confident we want to be that we haven't made a type 1 error. The lower we set this value, the lower our probability of making a type 1 error. But this alpha level is the thing we end up comparing our p-value to. Okay, so type 1 errors have a probability of alpha. Type 2 errors technically have a probability of beta, but we won't actually be doing anything with beta in this class. I think that is primarily, I'm just looking through our book here to make sure I haven't missed anything. That is primarily what's covered in this section. You're just going to be looking at the terms and definitions and concepts behind hypothesis testing, but you're not actually going to be doing any hypothesis testing until the next section, until we start learning when to use which types of hypothesis tests. So make sure to read through the book. If you need to, you can watch this video a second time to kind of absorb some of the concepts. Please work through the homework assignment, and if you have any questions on those problems, bring them with you to class tomorrow. Thanks for watching.